Chapter 2: Advanced Electronic Devices. Types of solar cell. Interconnections of solar cell. To increase their utility, a number of PV cells are interconnected together, which is in a sealed, weatherproof package called a panel or module. For example, a 12-volt panel or module have 36 cells connected in series, and 24 panel module have 72 PV cells connected in series. To achieve the desired voltage and currents, modules are wired in series and parallel into what is called a PV array. The flexibility of the modular PV systems allow designers to create solar cells power systems that can meet a wide variety of parameters and electrical needs. Generations of solar cell. Currently, there are 3 generations of solar cells, and some people say there's 4 generations of solar cells. It depends on the scientists or the researchers itself or the engineers to define this kind of technology. But as a brief categorical generation of solar cells, actually the first generation of solar cell is wafer-based, which is of course the silicon itself. Silicon, as you all know, has 2 types of silicon solar cells. The first one is monocrystalline or a single crystalline, and the second one is the polycrystalline solar cells. Then the second generation is focused on the thin film itself. So the first one is the amorphous silicon thin film solar cell and cadmium telluride thin film solar cell. And the third one is the new generation and the new emerging technology. This kind of technology examples involves nanocrystal based solar cell, polymer based solar cell, DSSC, perovskite solar cell, and also concentrated solar cell. We will learn this further in our next chapter. Generations of solar cells and its comments on PV materials and their developments. So for example, these are the efficiency and comparison and the disadvantages and advantages and their recent development in comparing with the other types of material. For example, this one is silicon. Okay, so the first one is monocrystalline, polycrystalline, and also the amorphous silicon crystalline. So you can see clearly here the efficiency is different, and of course the most high efficient is 20.4, which is from the single or monocrystalline silicon itself. There's a lot of advantages here. However, there's a lot of drawbacks, and also because this is the most expensive. For example, you want to compare with multicrystalline, right, with a 16.9 efficiency, with a difference of around 3% of efficiency. You have to really increase your expenses. So there's a lot of trade-off that you have to consider. Okay. However, this advantages is quite interesting because it is made from the purest form silicon and consume less space, of course, and longest lifetime ever because it is single crystalline, and of course because of the crystallinity it is more heat tolerant and they perform better in summers. However, with multicrystalline, even though with the disadvantages of the impurity and the larger area, it is easy to install and maintain and waste less amounts of silicon and therefore very cheap. In compared with the amorphous silicon, the lower manufacturing costs, it is lower than the monocrystalline, of course, and the advantages is produced in variety of shape and sizes. This is very attractive because you need to be able to manipulate shape and sizes of manufacturing of this kind of substrate, and it is easy to create the modules in variety of different voltages, very attractive, much less susceptible to breakage during transportation and installation, which is in contrast with the multicrystalline that is very quite brittle. So the advantages of this kind of morphosilicon thin film is actually, of course, the lower efficiency than monocrystalline for sure, or even polycrystalline solar cell. That is so unfortunate. And the manufacturing process are more complex than crystalline silicon. This gonna contribute to the more expensive cost. And however, the expected lifetime is shorter than these two, and this is very unattractive for this type of substrate. Other thin films such as CDTE and CDS and CIS and CIGS, the efficiency of CDTE or CDS is around 13.9, and the CIS and CIGS is around 15. Okay, the advantages are here is actually ease of manufacturing, simple mixture. This is very attractive. However, due to the low efficiency compared to the silicon solar cells, make it less attractive. And also, Te tellurium is extremely rare element, and also, unfortunately, it is harmful for environment, which is cadmium, which is very toxic. The advantages also involve good match with the sun captures at a shorter wavelength that is possible with silicon modules, similar, and also cadmium is abundant. And compared with the CIS and CGIGS, the advantages here is they consume less energy while manufacturing compared with silicon, and much lower cadmium is used, hence less harmful to environment and compared to the cadmium telluride. And also better resistance to heat than silicon-based solar cell. This is very attractive. However, the disadvantages are they are not as efficient as single crystalline or crystalline solar cells. However, the most efficient of the thin film technologies when compared with the amorphous. The cost of manufacture is higher, unfortunately. For the emerging technologies, compared with the hybrid cell, which has the efficiency of 17.8, which is quite high. And advantages is better resistant in low light. Disadvantages is complex manufacturing, of course, because it is hybrid. Compared with the CNT, still not available efficiency, but the advantages are they can convert 70% of light into electricity. However, CNT are difficult to produce. I mean, in terms of high quality CNT, it's very difficult to produce. In terms of DSSC, the lab efficiency is around 11%. It works on a simple PN junction assemble technology. That's the advantages. However, TiO2 is an expensive material. And tandem multi-junction solar cell, this is very high lab efficiency, around 44%. Advantages, of course, is high efficiency. However, because of the tandem structure, the structure is going to be very expensive. So as a summary, you can say that a monocrystalline panel solar cell mono single, the efficiency rate is around 20%. Advantages, of course, optimized for commercial use, high life and time value. These advantages are expensive. Polycrystalline panel solar cell is around 50%. However, it is very cheap compared to the single. And these advantages are its durability and also the space consuming. Thin film amorphous, 7 to 10%. Relatively low cost, easy to produce. However, the lifetime is not so good. And concentrated PV solar cell, this is very high efficiency rate and higher performance. However, the disadvantages are it requires solar tracker and cooling system to achieve this kind of efficiency high rates. So as a brief technology development roadmap, you can see here actually the actual stages of these kind of technologies. So of course, the most recent and attractive is quantum dots these current years, and this is actually in the early stage of R&D, and in between with the breakthrough. So perovskite leading on, which is a very interesting material. I will show more after this in upcoming chapter. There's a lot of interesting perovskite research in terms of solar cells. and CZTS is after the prototyping. Dollars 9 is still on pilot. Market entry for the DCSN C, which is quite interesting. And of course, the large scale manufacturing production is included in CDT, CSI, CIGS, and continuing the ALMA for silicon. That is all from me today. Thank you and have a good day.